before Ranran is going to give you the demo and the presentation, so I just say a few words here. So what she's going to do, Ranran is going to do, is to show you the high performance computing capability that we have in the CyberWater framework. So basically, you know, the CyberWater now is for your desktop, right? For your desktop. And so for some of you, if your model is complicated, for example, its watershed size is large and the resolution is high, and you have a lot of data and you have to simulate it for years, you know, so it needs a lot more resources, that computing resources that the desktop, your PC can provide. So at that point, you probably need some high performance computing facilities to help you. And but if your model, your study area is small, you probably don't need the high performance computing. You just use your desktop. That will be very convenient for you, and you don't need to pay for the high performance computing, right? So for that reason, we have this high performance computing. We call it on demand. That means if you need it, you can connect to the high performance computing facilities. So that way you use them only when you need it. But if you don't need it, you just run your model on your desktop. That would be good enough. That way it gives you a lot of flexibility and you save your money as well. So and in order to do this on demand, so we develop this high performance computing module, which is one of our generic model agent tool, one module in that set. And this module, whenever you want to run on the high performance computing, you need to use this module. Okay, so that is a brief, that is a background for this on-demand high-performance computing facility. Okay, it's your floor now.
Okay. Can everyone see my screen right now?
Yes.
Okay, yeah. Hello everyone, thank you for coming. And today I'm going to introduce the high-performance computing module in CyberWater. And firstly, let me give a brief definition on what exactly is high-performance computing. High-performance computing is the use of parallel processing and supercomputers to run advanced and complex application programs. The system focuses on developing parallel processing systems by integrating both administration and computational methods, and HPC was developed to meet the increasing demand for processing speed. And for right now, the CyberWater HPC module enables users to access the HPC resource on demand using agents. And right now, we have two ways to access the high-performance computing platform. The first one is just connect to the HPC platform directly via the SSH protocols. And we also support the gateway, which integrated mode platform and provide a graphic interface for users to access the platform. And this diagram showed how the texts are uploading to HPC directly or through a gateway. So far, there are two types of HPC platforms supported by CyberWater. One is the academic, which belongs to university or some other academic institutions, and the user only need to apply for a computing account by their academic email address, and they can use the free HPC resource. And we have the Pittsburgh bridges, including large memory and regular memory, and the Pittsburgh GenString and IU Big Red 3 as the academic HPC platform. Besides, we also add a commercial HPC plan for the Google Cloud. And it is charged, but if you apply an account by your academic email address, you will get 300 credits at first for free. And from my own experience, it might only cost you less than 3 credits a day if you keep your instance open on the Google Cloud the whole day for 24 hours. So it might be kind of friendly for academic researchers if you don't have any other academic HPC platform. So take a bridge as an example for the academic HPC platform. We use SSH protocol to connect the platform, and the requirement is that you must to meet in advance is that you need to have an exit portal account for bridge. And I think you all should have that experience to log in a server by the password and the username. So if you don't want to type this stuff every time while logging, you can fill the form and set your public key to the bridge. And after that, you will receive a conversation from the bridge. And from then out, you don't need to type in any password or username while you're logging. Google Cloud is the thing. We also use the SSH protocol to connect it. After you're creating an instance on Google Cloud, you will be a cluster administrator, and you can add other users' public key to this instance. And then the user can also access your instance so that you guys can share one commercial HPC resource. For the gateway, right now we are using the CyberWater framework and running it on the IU Bloomington Computer Center. It is a pretty similar as the Google Cloud that you only need to configure an instance and then add other users to access it. But right now we support 2 platforms, the CARST and the Pittsburgh Bridge. So right now you can access it through the gateway to the Pittsburgh Bridge by directly or using our gateway. There is an import port specification for HPC module, and I will give you a demo on how to use the HPC module in a workflow. It is a pretty similar as the RAN module agent in Agent Tools. I guess you have already tested before and using it to generic weak agent and routing agent. So basically in the workflow, the RAN module agent is replaced with HPC module so that the computing can be processing on HPC platform instead of the local machine. The new parts added to this HPC module besides the RAN module agent is that we can see you need to type in your username, your password to log in the platform, and you also can set the runtime. That is the duration of the task in the platform, which users want to apply for, and the default value is 5 minutes. So if you think 5 minutes too short, you can change it. And we also add email as a typing entry, because it is that you will receive an email from the HPC platform when the computing is finished. And I guess you have that experience that computing percent is too long and you don't want to keep your eyes to monitor all the time. So it might be convenient for you to receive an email to be notified that the process is done and you can check it. And the output part is identical with the RAN module, and it also supports 5 database dataset as the output. This is the interface of the HPC module, and you just need to drag the HPC module from the high-performing computing tab, and then type in some relevant information. And the detailed operation will be given during the demo later. And I will using the French Creek dataset to generate this workflow. And I think you have used this dataset, the French Creek, to test the weak model before as the instruction in the user menu. And the basic idea for the HPC module is to upload the forcing data, which is generated by the forcing data file generator, and then doing some computations in the HPC platform, and then download the results from the HPC platform, and then show the result chart. Okay, let's begin the demo. So this is the workflow that using the dataset of French Greek. And that is the local one. I guess you might be pretty familiar with that. And I just use the HPC module from here. The high performance computer tab, just need to drag it out and replace with this part.
Excuse me, Ranran.
Yeah.
I guess the screen you are sharing is still the presentation screen, not the desktop yet. And so you need to stop sharing this one and sharing this other one.
Okay, my fault. Sorry.
No problem.
Yeah, can you see my screen right now?
Yes.
Yes.
Okay, let's restart. That is the workflow that to generate the weak agent, and I use the French Greek dataset. So what we need to do right now is just to drag the HPC module from the high performance computing tab, and then replace this part. Replace the RAM module agent part with the HPC module. So I have already done it in order to save the time. So the workflow before is all identical. And for the HPC module, what we need to do is just to type in the email address, just pretend them, and some password. Yeah, I have already to improve the password privacy to make it password hidden while it's typing it. So it might be a good feature for us to save the virtual file because the password will not be obvious in this file. And what else? You need to have a CyberWater to be the project name because it will be the folder name in the HPC folder. And your username. I must to mention that in this HPC module, because the platform is in Linux system, so if you just use the executable program which compile in your Windows operating system, it maybe cannot run in the HPC module. So we have two choices here. You can just upload the exact executable file which is compiled already in the Linux system environment, or you can also upload the source code and give us the name of the executable program written in your make file so that we can find your executable program in the HPC platform. So for right now, because I don't have the executable file compiler in this computer, so I just upload the source code directly, and it is the VicNout. It is the name of the executable file in the make file string. So after that, okay, let's executable it. And we can see some, message in the console. It is going to upload the forcing data file. And we can see we have successfully submitted our job on a cluster. and they assign us a job ID. And it shows the status of our job. The PD is short for pending, and we need to wait for 30 seconds. Okay, let's scroll up. I want to show you other things. Yeah, and after we connect to the bridge, there is the resource info showed on the console, like the partitioned node, CPUs, and the memory, and the time limits, and whether it is available. Yeah, we still need to waiting for another 30 seconds. It sometimes happens because you are waiting in a line for the resource allocation. So sometimes it will be pretty fast. Sometimes you need to wait for a long time.
Yeah, one thing I want to mention is that this Bridges is from Pittsburgh, and during this COVID time, we have received a number of information email from the supercomputer center here in Pittsburgh, because they allocate, they have the priorities to do everything related to COVID-19. And so they told us that, and so that's why sometimes you have to wait, like then showed you guys.
Yeah, thank you, Dr. Liang. Yeah, and we can see it will be pretty fast. Just in a second, the computation is finished, and then it will downloading the results from the HPC platform and then show the results. Here is the show chart. And I mentioned before that we will receive an email from Learned when your job is finished. So that is the email I just received. Okay. So this is a demo for the bridge large memory. And this time I wanted to try the gateway. Because we have a two-way to access the Pittsburgh bridge. One is just connected directly, and one is through the gateway. Yeah, that is the thing. Uploading, and yeah, during this time, I wanted to show you guys the interface of the protocol of the gateway. Could you see my screen?
Yes.
Okay, yeah, so that is the gateway. And I have already logged in, I guess. And because the gateway provide graphic interface, so you can find your project in your gateway. So that is our gateway project, CyberWater gateway. And then you can find some location. Like, because we have already created an location is CyberWater HPC resource, and then we can find there is a cast and the bridges. So it will be pretty straightforward to have this interface. Let me check how it's going on. It's still pending.
Pittsburgh is busy with COVID-19 research.
Yeah. Because I tried yesterday, I just need to wait for a certain second, but today, I should wait for at least 2 minutes.
Yeah.
Okay, let me check this one. We are still waiting. Yeah, but I guess from my opinions, the time what time costs most is just to waiting the node and uploading the forcing data, because our data, this data set for the French Greek is a pretty small, so it cannot show the advantage of HPC module very perfectly. If your data set is pretty large and you will need a long time to computing it, the HPC will be pretty useful.
Yeah, I want to for that I want to jump in then and to share what we saw on the screen you demonstrate to us during our weekly meetings. So basically, Yang and then had a weekly meetings with Daniel and I, and they showed us that when they tried to run the West Susquehanna River Basin in the, if I remember correctly, on the HPC, it was really fast. But you know, some of you have already finished the generic tool, which is section 4. You know, at least on my PC computer, it took a few minutes, but then on the HPC, it's just seconds. So that is an example where you see the advantage of using the HPC. And obviously, if you run high resolution model and also large watersheds, then HPC is a big has a big advantage of that.
I just have a question. This is Rick. So when you're executing it, does that mean when the data agent executes, is it loading the data locally to the HPC resource, or is it on your own computer? Because it's a big problem, right? Is when you have simulation runs that have large data files, let's say for inputs. That's always a problem, right? Moving those around the internet. So are these files then, are the data files located on the HPC resource?
Yeah.
Okay. That seems to be a big advantage to have the data agent execute.
Yeah, that's true.
On the HPC, okay. And presumably the HPC has a fast internet connection as well.
Rick, so basically right now, the data needed to be transferred from your local PC to the supercomputer, to the high performance computing platform right now.
That's a limitation, right? Because that could be a problem.
Right, exactly. So now the data you need to transfer to from your local desktop to there, and in the future we want the data can be directly accessed from the high performance computing platform. So that way we don't need to do this transfer. So that would be the that will be our future plan. But currently, it's just we have to transfer data from local to the supercomputer.
Yeah. So far we are forcing our data file locally on our local machine, and then I need to upload the forcing data to the HPC platform and do the computations.
I see. Then, I see the workflow, yes.
Yeah, so in the future, maybe we can just generating the forcing data in the HPC platform directly. It will save a lot of time for the uploading.
Right. That is a problem. I mean,
yeah.
Particularly for hydrology models as opposed to MET models.
Okay.
So much, there's so much of this data that has to be transferred out. Okay, thank you. Sorry,
So we can see the result is the same. No matter what platform you use, or directly or through the gateway. So at last, I wanted to use the Google Cloud, the commercial platform. And besides, I wanted to try this way because I wanted to make a comparison with the local one and high performance computing platform. So I will run this at the same time. So we can see that there is a batch file and it's changed to the CyberWater Google Cloud dropped. I'm not sure which one will be faster.
Well, obviously the execution would be much faster on the HPC, but then including the waiting time, though, who knows?
Oh wow. Oh, much faster. Okay.
Wow.
Yeah, it seems the Google Cloud. Yeah, because the blue line showed for the HPC one and the local one is the green line. However, they are at overlap, so it's the thing.
That's good news.
Yeah, that's good news. Yeah. Yeah. So that is the demo. And at last, I wanted to show the Google Cloud Consort, because the Google Cloud also have a graphic interface. So if you, okay, this one. Yeah, so that is the Google Cloud Platform Console, and that is the dashboard, and you can monitor your activity here. So that may be the advantage of the Gateway or the Google Cloud. Yeah, so thank you. That is my presentation today.